Welcome everyone. Last time we saw how to find the equation of ellipse and also some other properties of ellipse. Today what we are going to see is also an ellipse but not exactly. Why I am saying this? Today also we are going to see an ellipse because those are very connected but in a slight different it became hyperbola. Let's see. There must be two separate parts in an hyperbola. Both have two separate foci. We can get a common point P. So to get the simplest equation, let's move our foci to the x-axis. And also we are setting our foci is basically at minus c comma naught and also other focus at c comma naught. So those are our foci. Let's make an equation for it. So length p of 1 minus length p of 2, which means a difference between those lengths. In here in picture I took that p of 2 is great and p of 1 is less than that, but in a common case I have to tell that it can be both. I take that length could be 2a or minus 2a. So first I take it's 2a, which means it's positive, and also that means pf1 is greater than pf2, that length of pf1 greater than pf2. Okay, let's substitute our values x, y. So we will get the length x plus c all things squared plus y squared minus square root of x minus c all things squared plus y squared equal 2a. As we did in ellipse, here also we have to take our 1 square root to right side. So simply we will get some parts disappeared and also we will get, so 4cx equal 4a squared plus 4a into x minus c all things squared plus y squared. Then we can divide both equation by 4, then we will get the cx and also other things. Then next step, I take the x squared to left side and make the square root in an isolated place. Then we have to make another square at both sides. We will get simply like this. Here you can see most of the elements can be factorized. Also it seems like an ellipse equation, but it is not. After we have done this, to get a simple equation, we have to pull out the minus from the equation, then we will get, then we can substitute c squared minus a squared as b squared, then we will get a simple equation. Then we can divide this equation both sides by a squared b squared. We will get a similar equation to ellipse but with a minus sign in front of y squared over b squared. So far we have done that case 1, so we have to prove the case 2 also. You can do the same thing as we did in case 1. After you get this step, you may see these absolutely equal to the first case, so we can neglect and we will get the same answer, such is that is 1 equal x squared over a squared minus y squared over b squared. Okay. Here also we can find the x-intercepts by setting the value y equals naught. So x squared over a squared equal 1, x equal plus or minus a. So our graph should be cut the x-axis at a comma naught and minus a comma naught. So these intercepts are maybe called the vertices. Also we can find the y-intercepts. But how? Setting the value x equal naught. Once you did that, you can figure out that it's not impossible, because square never get an minus value, so which means there is no y-intercepts in our graph. Then we can prove another thing by take the y squared over b squared to other side. Then we can say that this is greater than 1. So we will get x squared over a squared greater than 1, which means so our x value should be greater than a, or it should be less than minus a, which means there is no point between a and minus a. And finally we can conclude by taking 1 and 2 that there is no such coordinates in our graph between a and minus a. So our graph should have two branches. Now we can prove another important property here, that we can take y squared over b squared to right side, and also we can see this is greater than y squared over b squared, which means our x squared over a squared should be greater than y squared over b squared always. We can simplify this equation as we did in above part. So finally we will get an inequality that our y value always between minus bx over a and bx over a. Such that we can define our asymptote as y equal minus bx over a, also y equal bx over a, which means our value which means our y value which means our y value never gets those values, but when we increased our x towards infinity, we may reach that y value. Okay, so we can say these lines as our asymptotes. I assume that you are understood it very well. In order to draw a hyperbola, it's good to draw the asymptote first. Then you can start your hyperbola at very end of the asymptotes, then you can get hyperbola. So we have to point our foci, which are at minus c comma naught and c comma naught. Also our vertices at minus a comma naught and a comma naught. You may find in ellipse we uses b coordinates, which means b as a coordinate, but here we don't use it. We use that b coordinate only in asymptotes. So finally, this is our equation for hyperbola. Let's note another small thing, that if our b is equal to a, here we get x squared minus y squared equal a squared. We can call it the equilateral hyperbola. Where our asymptotes, you can find that x equal plus or minus y, or y equals plus or minus x. So these are perpendicular, that is obvious. Also we can get an important graph from this equilateral hyperbola by turning this hyperbola by an 45 degrees. Our asymptotes become x and y axis. Also then the equation become xy equal k, where k is constant. It's not needed for us, but we have to know about this. Let's move on to our first example. 9x squared minus 16y squared equal 144. This is the equation of hyperbola. So let's divide both sides by 144. We will get x squared over 16 minus y squared over 9 equal 1. This can be seen as a hyperbola. So we can find our c value, where we don't need to consider about which is a or b. Finally we get the answer for c, that is plus or minus 5. But how can we ensure that our foci is at plus or minus 0? not the 0 comma plus or minus 5, where it is also similar to our ellipse method. Once we have arrived our equation of hyperbola, both x squared and y squared have a squared and b squared values, where which one is have a highest value, whether x or y, that axis gets the power to have a value. Okay, this is simple. A value means vertices, so we can use this knowledge, this idea to complete, to do our equation. So we can get our asymptote as y equal plus or minus 3 by 4 into x. So let's sketch our graph as we have done before. It's good to start with our asymptotes. So we have drawn our asymptotes. Let's point our focus points, which are minus 5 comma naught and 5 comma naught. Then we can point our a value, which is vertex, that is a 4 comma naught and minus 4 comma naught. When we interchange x and y, so we will get y squared over a squared minus x squared over b squared equal 1. Where we know that which axis have big value, where b is always big. So vertices are at 0 comma plus or minus a, not plus or minus a comma 0. Okay, and also our for c is denoted by c, and c squared equal a squared plus b squared. So we will get 0 comma plus or minus c, not plus or minus c comma naught. So our asymptote is also x equal plus or minus b over a into y. Let's move on to our second example. Our vertices are 0 comma plus or minus 1. It's looking same as we proved before. So we can find our a value, that is 1. Also we have given that asymptotes y equal 2x. By previous proof, we can simplify this equation as y equal a over b into x. Already we know a equal 1, so our b should be half. So let's find the c value. C squared equal 1 plus 1 by 4, which is 5 over 4. Then our c value is plus or minus root 5 by 2. Okay, since we know all sufficient values to find the equation of hyperbola, let's find it. So here our equation should be y squared over a squared minus x squared over b squared equals 1. So let's substitute our values. We get an equation like this. Let's draw our hyperbola as we did before. First we have to define our asymptotes and draw it. Those are y equal 2x and y equal minus 2x. Let's point our for c, and also we can draw our graph. Here we first use the vertices instead of foci. It's also possible because we are drawing a approximate graph, not an exact graph, but we have to point our important points. Okay friends, so far we have done our all conic sections. So let's meet you at next video. Bye bye.